Hello everyone, welcome back to another video. In this video, we'll be looking at NCEA Level 3 Spectroscopy. So spectroscopy requires you to essentially know how to read three spectrums. First is the mass spectrum, and then it's the IR spectrum, and the C13 NMR spectrum. So I like to start with the infrared spectrum, and then working my way down to carbon-13 NMR, and then lastly doing fragmentation analysis with mass spectrum. So let's take a look at with our IR spectrum. If we look at our data sheet and our spectrum, we see that there's one peak here that's quite broad, and it's between 2800 to 3500, 3300. So that indicates OH or NH, but it indicates an OH because it also overlaps the CH bond, CH peak over here at around 3000. So that indicates an OH for carboxylic acids because it overlaps the CH and it's very broad. So this indicates a carboxylic acid. Now, what's something else that we could use to back us up is this peak right here. It's at around 1700, which indicates a COO. And obviously, COO is indicating us carboxylic acids as well. So, yeah, we can already say that there should be, or there might be, a COOH. Now we'll work our way down with the C13 NMR. We're gonna copy what we have before down so we know what we are looking for. Looking at the C13 NMR spectrum, there are 4 peaks, so there are 4 carbon environments. Therefore, there's a minimum of 4 carbon chains. There could be branches off of any carbon, but yeah, there's at least 4 carbon, at least a 4 carbon chain. Now let's look at its ppm. There's one at 180. Looking at our data sheet, 180 indicates COO for carboxylic acids, acid chloride, acid Cl, amides, and esters. So now it's our now we need to cross out 3 of those and conclude that it's the 4th one. That is our organic compound. So let's look at the other peaks. They're just below 40, so indicating either carbon and nitrogen, or just CH2 and CH3s. So not too much to talk about, but what we can do is already mark out that it's not an acyl chloride, because a CCl bond has a chemical shift at around 40 to 45. There's nothing in this region, so there are no CCl bonds, so therefore there are no carboxylic acids. Now for esters, there should be a chemical shift at around 60 to 80. Obviously, no peak at around 60 to 80. So it's obviously not esters. So that leaves us with carboxylic acids and amides. Because there is a peak at around between 30 to 40, or more like between 35 and 40, we cannot rule out a C-N bond. So not that I can think of that we can rule out amides. So it could be an amide plus an alcohol and a CO double bond, but anything's possible at this rate. Right, so now we've concluded that it might be carboxylic acids or amides, and that will be a good chance for us to move on to mass spectrum, where we look at fragments. First of all, we can see that this is the N plus peak at 88. This number is even. Using the nitrogen rule, it means that there are 0 nitrogens, no nitrogens. Hence, between carboxylic acids and amides, we can rule amides out. So it's a carboxylic acid. Now let's take a look. Fragmentation analysis, I feel like is quite useless, at least at our level, because just by using this mass, you can figure out everything already. So now we know it's a carboxylic acid with at least 4 carbon, at least a 4 carbon chain, with the possibility of branches. We can take a look. So let's put in 4 carbons first. That would be 12 times 4 because carbon has a molecular mass of 12. And we know that there are 2 oxygens because of the carboxylic acid. So we're going to add 2 times 16 because 16 is oxygen, mass of oxygen. That already gives us, so that's 48, and that is 32. That gives us 80 already. There's no room for another carbon, so we can say there are 4 carbons, 4 Cs, and then the 8 comes from the 8 hydrogens because 1, 2, 3, 4, 5, 6, 7, and 8. So this N plus peak already mean that we can conclude the exact shape of the molecule, which is a 4 carbon butanoic acid. But of course, to get E and to achieve merit excellence, you need to analyze at least, I think 2, 3, 4, I don't know, some fragments. So let's take a look. First peak I can see is at this peak at 73. Now there isn't a molecular ion that is that 73 indicates, but what we can do is to see what fragment is lost in this molecule for it to have a mass of 73. So we can do some subtraction. 88 minus 73, and that gives us 15. 15 indicates a CH3 plus ion, which is valid because that's just this carbon. But that's not too useful. So we can look at the 60, but let's take a look at if the 60 is helpful. Again, 60 doesn't indicate anything in particular, so we can do 88 minus 60. That gives us 28. 28 indicates a CO plus, and that does say something because it indicates this part. When the H is lost, we're left with C bond, single bond O plus. So that would be another ion that could be lost, and that indicates either alcohol or carboxylic acids. As a side note, if you see a mass of 18, that's H2O, and that's likely to be water loss, and that's likely to indicate alcohol because yeah. And now we can take a look at these bonds right here. There are a little cluster of them. We can take a look at particularly one first. Maybe at this is at 45. 45 indicates by itself. It indicates COOH plus, or it indicates others 2 other things as well. Like and the 2 other things are ethanol and other ions related with ethanol, which is not our case because we are quite confident that it's already a carboxylic acid. We're just looking at fragments that could still back us off. So 45 indicates COOH plus ion, and this is very helpful because that's just our carboxylic acid group. And now there's another one we could look at, which is 88 minus 45, because we can look at what is the other product when COH plus is lost, and that is 43. At 43, there is a peak. And if we look at our data sheet, that indicates C3H7 plus or CH3CO plus, which is not too helpful because we know it's not an alcohol. C3H7, that indicates that, well, the other part that is lost, the other fragment. And these two combined would help us identify that it is that there are 4 carbons and it is a 4-carbon chain. So we've analyzed 1, 2, 3, 4 fragments, and that is, I'd say that's more than enough for excellence already, if you've done this correctly. And yeah, in conclusion, it will be butanoic acid with something like this, and of course your hydrogens along the side. This is a very quick run through of the past of this practice question. Usually you'd have to fully write down what every peak and everything shows and what it doesn't show as well. So like, this shows a broad peak, so it indicates OH for carboxylic acids, and therefore it means it isn't something, So that's the type of stuff you have to be writing about for all 3 spectrums, and then creating a report, just combining everything and talking and having a proposed structure of molecule. Hope this helps. Good luck for your internal, and thank you for watching.